Hello, my name is Jennifer Rojas, and I was in a group with Veronica Rodriguez and Salvador Vega for our Science 1100 presentation. In our presentation, we covered the hybrid rocket engine experiment. So the first thing we covered in our presentation was the anchor phenomenon. An anchor phenomenon is something that is observable, and these observations then become the basis of an anchor phenomenon question that drives not only the teaching but also the learning. And this is a question that a student might ask. So our group decided that our anchor phenomenon question would be, how does the engine of a rocket have so much power? The next thing in our presentation is the investigative phenomenon. So what is an investigative phenomenon? Well, an investigative phenomenon is like a branch off the anchor phenomenon. It is what students observed after seeing the results of testing the answer to a question that relates back to the anchor phenomenon. Our group decided that the following investigative phenomenon question would fit our presentation. So it is, what causes the bubbles to form, and will changing the oxidizer make a difference? Next, we had to define our variables. In an experiment, variables are the things that are changing. Usually experiments have the following types of variables. There's the independent variable, which is a variable that the people conducting the experiment change. Then there's the dependent variable. This is a variable that the people conducting experiments observe because they're trying to see how it reacted to the changes. And finally, there's a controlled variable, and this is a variable in which the quantities of the said variable remain constant throughout the whole experiment. Okay, so now that we know what variables are, we can now define them for our experiment. So our independent variable was the oxidizer, whether it was the yeast or the baking soda and lemon juice. Our dependent variable was how long the bubbles lasted. So we're looking at the reactions that occurred for the hydrogen peroxide and the yeast, as well as the reactions that occurred for hydrogen peroxide and the baking soda with the lemon juice. Our controlled variable was a 3/4 cup of hydrogen peroxide, the mason jar, the non-screwed lid with the hole on top, and the ziti pasta. So next we made a hypothesis. Our hypothesis was that the oxidizer, whether it was the yeast or the alternative, which was the baking soda and lemon juice, would cause the bubbles to form, and the bubbles will stay there for the same amount of time, even if we were to change the yeast to its alternative.
Okay, so now we have three chemistry concepts that we must know in order to fully understand what's going on during our experiment. And the first one is oxidizer, then we have oxidation reduction reactions, and we also have combustion reactions. Okay, so what is an oxidizer? An oxidizer is a type of chemical that a fuel requires in order to burn. Most things use up oxygen to burn, and in Earth, that oxygen occupies our atmosphere. However, in space, there is no atmosphere to provide it. So, how do rockets fly up so quickly? Well, rockets have to carry their own oxidizers, and these oxidizers are placed in a separate tank, then released proportionately to the fuel source when the rocket is being fired. Now that we have that knowledge, we have to define what the oxidizer in our experiment is. So for our hybrid rocket engine, we know that um, these hybrid engines use a combination of a solid, liquid, or gas oxidizers. And in our experiment, our solid fuel is the pasta and the oxidizer is the yeast. But we also used alternatives of yeast when baking, which are baking soda and lemon juice. Okay, so now we have to understand what oxidation reduction reactions are. So in order to understand this whole concept, we must first understand each individual definition. So oxidation is the gain of oxygen. It can also be the loss of electrons and the loss of hydrogens. Reduction is the loss of oxygen, and it can also be the gain of electrons and the gain of hydrogens. So now that we know the definitions of each term in oxidation reduction reactions, we can now explain what the full process is. So for these reactions, they are a type of chemical reaction that involves the transfer of electrons between two species, and it is also any reaction that involves the oxidation number of a molecule or atom to change by the gain or loss of an electron. And these reactions are very common in life and are needed for combustion. So for our project, the first oxidizer that we used was yeast and hydrogen peroxide, and then we had oxidizer 2, lemon, and baking soda mixed together, and both of these helped us create the combustion we needed for our engine.
What are combustion reactions? Combustion or burning is a high temperature exothermic chemical reaction between a fuel and an oxidant, usually atmospheric oxygen, that produces oxidized, often gaseous products in a mixture termed as smoke. Hydrogen, butane, methane, and ethylene are examples of flammable gases. Combustion reactions always involve O2 as a reactant and release energy in the form of light and heat, referred to as burning. This is an example problem where carbon and hydrogen added with oxygen is on the reactant side, and the product side consists of CO2, which is a gas, the combustion gas, and H2O, which is water. The hybrid rocket engine experiment reaction consisted of yeast and hydrogen peroxide on the reactant side and carbon dioxide with water on the product side. The carbon dioxide was a combustion gas with the excess of water. Balancing this equation was really hard since they all have really big numbers. For this reaction, the flame was fluttering a little bit due to the bubbles throughout the reaction. They started rising and they blew the flame out. So from using 3 grams of yeast, we used the molar mass and mole ratio. The result was 10 grams of hydrogen peroxide that was needed to fully react with hydrogen peroxide. We got this with 3 grams of yeast, then moving on to divide the molar mass of yeast, then multiplying it by moles of hydrogen peroxide divided by moles of yeast. So now the molar mass of hydrogen peroxide is multiplied and rounded to the nearest 10 grams of hydrogen peroxide. A brief explanation of our experiment. So the question is, what causes bubbles, and does changing the oxidizer make a difference? Well, the answer, the bubbles, are caused due to the reaction that occurs between the yeast and hydrogen peroxide, known as the oxidation reduction reaction. A change in the oxidizer made a difference when producing a flame, but the oxidation reaction still occurred, therefore bubbles still formed. As we see in the picture, the mason jar is filled with hydrogen peroxide and yeast that is listed as oxidizer number 1. Now, oxidizer number 2 is lemon juice and baking soda. So the brief explanation continued. When oxidizer 1 was used, we got a successful exothermic reaction as shown on the picture to the right. It pictures the carbon dioxide rising to the top, which is burning off, and the water that stays below. A good observation that we noticed was how the amount of oxidizer influenced the overall flame produced. If we used too much, the bubbles would rise and put out the flame, and if used too little, the flame would be difficult to put up. On the other hand, when we tested oxidizer 2, the exothermic reaction was not successful, as it was impossible to get the flame. This could be due to the lack of oxygen that was produced by oxidizer number 2. From this test, we still got oxidation reduction reaction, which resulted with the bubbles. As we look at the picture to the right, it also looks like if it's shampoo on the bottom with all the bubbles on top. So now we have the connections to the NGSS. From cross-cutting concepts, it shows in grade 6 to 8, MS-PS1-4, develop a model that predicts and describes changes in particle motion, temperature, and state of pressure substance when thermal energy is added or removed. This relates to how there was a change in temperature and the thermal reaction increased in the liquid. From science and engineering practices, it mentions planning and carrying out investigations in 9 to 12, builds on K through 8 experiences and progresses to include investigations that provide evidence for the test, conceptual, mathematical, physical, and empirical models. This relates to how we solved for the empirical data and distributed even weight through the experiment. The excerpts from disciplinary core ideas explain from PS1.B. Chemical reactions. When two or more different substances are mixed, a new substance with different properties may be formed. This relates to how hydrogen peroxide and yeast mixed, creating a different property. The different property was carbon dioxide as a combustible gas.